Hello all. Today's video is going to be it's going to cover section 1.4, solving radical equations. Um, just a quick note. This is if you're concerned about my other videos being a bit long, because I do them, they're typically around an hour, because that's what I'm used to in the classroom. This one is going to be pretty short, and not because there's not a lot of potentially good information in section 1.4. If we're doing this at a pre-calculus level, we would be diving into this like head first. But part of the problem with a lot of the content in section 1.4 is to kind of to appreciate what's happening so that you can apply it later, like in calculus. You really kind of have to have your like those all those skills that we practice in a review chapter. You kind of have to have those down cold without even thinking about them. So like if the entire class was such that we could skip the review chapter and start with chapter one, we would definitely be doing more in 1.4. But since we need to do that review chapter to get everybody's skills up to speed, we're not gonna. A lot of 1.4 ended up feel like very tiresome, busy work for a lot of you, and that's not my goal. I want you to at least have some appreciation kind of for what we're doing and be able to think about it as you're going along and not just feel like it's a slog. So, um, and that sort of stuff I'm talking about is not core for what we're doing in the college algebra class. And so we're going to do just one type of equations with radicals, because that is something that will pop up occasionally and kind of goes along with what we're doing without being like a next level up. That's why this is going to be a bit short. I think in MyMathLab there's only 5 questions in this homework set. Um, well, it's pretty straightforward compared to some of the stuff we could have been doing in 1.4. If you are going on calculus, again, if you ever want extra work, let me know and I'll make an assignment from 1.4 with a lot of the fun stuff in there, but just for you. But that's what we're doing today is we're just doing equations with radicals. All right, so let's just jump into the notes. All right, so anytime we say radical equations, that just means an equation that starts with a square root. It could be a cube root, it could be a fourth root. Um, for the most part, we're dealing with square roots. And the nice thing about these radical equations is they're really, connected to the square root property. So if you've been working on your 1, 2, 1, 3 homework, there's the solve by factoring, solve by quadratic formula, and the other method of square root property. This is since square roots and something squared are inverse operations, this is very much tied to how we were doing the square root property. Okay, so if you practice that, um, this should this should feel familiar. If you haven't got a chance to practice that yet, you may want to wait and at least do that part of that 1, 2, 1, 3 homework before watching this. I think this will go a little bit quicker if you've done your square root property. All right, so how do we, we're still solving equations. And so how do we solve an equation that has, a square root in it? We'll talk about one with a cube root, but like I said, we're really focusing on square roots here. Well, the messy part is if we're trying to solve for x, well, in this case, there's an x outside the square root, x inside the square root. Let's ignore that x on the outside at the moment. If we're solving for that x, we need to get it outside of the square root. And so how do you do that? Well, when we're solving equations, we're generally doing opposite operations. So how do what's the opposite of square root? It's squaring something. And that's why I said this is related to our square root property. Right? And so just like with the square root property, when you had to isolate your square term by itself, that's the first step in solving these radical equations, is you have to get the radical term to isolate it on one side. Like on number 5, that square root, that's isolated. So step 1's done for number 5. Number 4, there's that 7 times the square root of x. So to isolate that square root of x, first thing you would do is divide both sides by 7. That's what I mean by isolate the radical on one side of the equal sign. And we'll do more examples of that. Once you do that, once you have that square root by itself, you're going to square, or we are going to look at one that has a cube root. What's the opposite of cubing? The cube root of something? Well, it's cubing it. So whatever that radical is, you're going to square or cube both sides. Just like with the square root, we're taking the square root of both sides. And then once we have that, then we have an equation that as long as it has one square root in the original problem, once you square both sides, you should no longer have a radical left. And then you're back to solving either a quadratic formula or a quadratic equation or a linear equation, just depends on what you ended up with. Now, some of those problems 1.4 that we're not going to get to are actually problems that have like two squares in the problem. And so basically you have to kind of go through this whole process twice, because the first time you square it, you're getting rid of one square root. Then you have to do a lot of simplifying and manipulation. Then you square it again, that gets rid of the second square root. So that's why I say like we could get really in depth with these, but we're not for this course. Let's see. The one thing I will point out now, and I'll point out again, is when we're doing square root property, when you take the square root of both sides, you have to do plus or minus on one side because, like let's say that you're squaring 25. Well, you don't know if originally it was positive 5 that you're squaring to get 25 or negative 5 that you're squaring to get 25. So that's why when you're doing square root of both sides, you have to do plus or minus. But if you're squaring both sides, let's look at this one. So if you're squaring this one, when you square a -3, it's not going to be plus or minus. It's going to be a positive 9. Anytime you square a number, it's always going to be positive. We're talking real numbers. So we don't need the plus or minus when we're squaring both sides, just when we're square rooting both sides. Right. And then, like I said, once you square both sides and get rid of the square root, you're going to solve it as necessary. I think it's spelled correctly. The program I use doesn't have a spell checker, so the one extra step that we haven't done so far is you always have to check your answers when you're starting with a radical equation, particularly with square roots. And the reason being is sometimes we get what's called extraneous answers, like the algebra leads us to a number, but if you take it and plug it back in, then it's not going to work. Okay, and that happens because when you're squaring both sides, you are introducing potential for false answers, basically. So, well, and that's something that people tend to miss because you don't do it anywhere else so far. There are a couple of places throughout the semester we'll have to check our answers. When you take the square root of both sides, when you're solving radical equations, you do have to check your answer. So don't forget that last step. All right, so let's go through a few examples and see what we're doing. So, and also notice it says find real solutions. So, and this is a case where if we get a imaginary answer in MyMathLab, I think there's going to be like, and we'll check it before we're done. There should be like an A, here's the answer, and a B, there's no real solution. So again, watch the instructions. If they don't say real solutions, then we can have imaginary answers, but it all depends on how they coded the problem. Let's start number 2. We're going to solve square root of x plus 4 minus 4 equals 0. All right. Well, our goal is to get x equals. That x being inside the square root is a problem. Okay. Just a couple of things to watch out for. Can we add the 4 and subtract 4 and say that's 0? Hopefully you're saying no, because that plus 4 is inside the radical. So you can't deal with, terms inside the radical can't be added, subtracted, multiplied, divided, still stuff outside the radical. All right, so what do we do? Well, step 1 is isolate the radical term on one side of the equal sign. So we need the square root by itself. So we need to add 4 to both sides. Now we have the square root of x plus 4 equals 4. Okay. Once you have the radical by itself, since it's a square root, we're going to square both sides. Because what you do on one side, you got to do the other. And so why are we doing this? Well, the square root and something squared are opposite operations. They're going to cancel each other out. So on that left-hand side, we're left with whatever that argument is in the radical. So we're going to be left with x plus 4. And over here, well, 4 squared is 16. And again, we don't need plus or minus because 4 times 4 is positive 16. If that had been a negative 4, negative times negative still been a positive 16. So no plus or minus needed. All right, so that was step 1. So we isolated. Step 2 is we squared both sides. So now what do? We solve it. So, and again, at this point, this could be a linear equation, could be a quadratic equation, whatever is the appropriate technique, use it to solve. You get x equals 12. So are we done? Well, if you put in x equals 12, you may get lucky, but there is that extra step. Always check your answers in the original equation. So let's go through and check. So always go back to the original problem. Because if you check it in here, you're not catching what's happening up at the very beginning. So we got x equals 12, so plug that in. So is the square root of 12 plus 4 minus 4, is that equal to 0? Now I put equals over my question mark over my equals because we have to prove it. 16 plus or 12 plus 4 is 16. Square root of 16 is 4, so 4 minus 4 is 0, so that's good. So therefore, that is our answer. It's almost Murphy's Law, particularly on a test. If you don't check it, then you're gonna not get full credit, because if we get a false statement down here, what that means is we have to toss the answer that we checked. And if we only get one answer and it doesn't work, then our solution is no solution. If we have a quadratic equation that we're solving, it could be that just one of them works and the other one doesn't. It could be that they both work. It could be that neither of them work. You don't know until you check it. Later in the semester, once we start talking about graphing this stuff, then I can kind of show you like graphically how we're getting like the solutions. But for now, we're just doing the algebra part. So make sure to always go back, whatever your answer is, plug it back into the original problem, make sure it works. All right. Nice, very straightforward. We're not going to get too messy with these. How about number 3? Let's solve square root of 4x minus 3 equals -3. Kind of wish the numbers didn't match, but this is random number generator, so there's nothing special about those being -3s. It's just with the random number. So for solving it, what's the first step? Now, step 1 is isolate the radical, which is done. So there's no work to do there. We're good. So what is step 2 once the radical is isolated? Well, now we're going to square both sides. So that's a square. All right, so square root squared, opposite operations, they cancel each other out. That leaves us with 4x minus 3, and then -3, and that's parentheses are important. That's negative times negative, so it is a positive 9. And then once we do that, now we're going to solve. So this is standard fare. It's not in quadratic. Four x equals 12 divided by 4, get x equals 3. So are we done? Well, if you said no, just the last step for these is always check. So back to the original problem. So we're going to plug in 3. So 4 times 3 minus 3, is that equal to -3? So just take that number and plug it into the original problem. 12 minus 3, is that equal to -3? So square root of 9, is that equal to -3? Oh, here's how we have a problem, right? The square root, and the only way to get a negative answer if there was a negative out front. So square root of 9 is +3. +3 does not equal -3. What does that mean? That is a false statement. What that means is the one answer we got does not work. And so since the one answer we got doesn't work, that means our actual answer is no solution. Algebraically, there's only one number that would have worked, but if you plug it in, it doesn't. Now, this is one where if you're more comfortable with this, you may have looked at the beginning. Can a square root equal a negative number? No. So we could have theoretically said that was no solution right off the bat. But you do have to be careful with that, because if there'd been a negative out in front of the radical, then that could have been positive, and that would have made it negative, so that would have worked. Like on number 2, like, like here, if that had been like a negative number, well, we could get a negative number over here because we're taking something and subtracting something from it. So you can't always just, just because it's equal to a negative number doesn't automatically mean it's false. But if it's real basic like this one, square root equals a negative number, that one is false. So best thing to do, go through all the algebra, see what you get, check your answer, and go from there. Let's see. I'm going to skip, like I said, the first thing, I was on number 4. First thing you do there is divide both sides by 7. But from there, they may not look like it, but that algebra is kind of messy. So I'm going to save that one for now. If there's not one like that in MyMathLab, I'm going to skip it because that one's actually messier than it looks, because when you square both sides, then you got an x squared with a fraction equals x. That just, the algebra on that's messy. It's like a quadratic formula type problem. So we're going to skip that one for now. Let's see. In interest of time, I mean, I could do number 5, but number 6 is basically number 5 with one extra step. So let's do number 6 instead. Like once we do the first step, we're right back to number 5. So number 6 is we're solving -6 plus square root of 28x minus 28 equals x. And again, there's nothing magic about those, like those 28s. Those don't have to be like 10 and 10 or 5 and 5. That's just how the numbers. It's when you're trying to write these problems so that the answers come out to nice numbers, sometimes you manipulate things just to make the answer look easy, which sometimes makes it look weird at the beginning. But there's nothing special about those both being 28s, other than the math works out nicely. All right. So that aside, what is step 1? We have an equation that we're trying to solve that has a variable inside the radical. So step 1 is we're going to isolate the radical. So we're going to add 6 to both sides. So we get square root 28x minus 28 equals x plus 6. Now the radical is isolated. And that's why I said, if you look back on number 5, once we're right back to number 5. So 2 is we're going to square both sides. And we are squaring the side. So you need to put parentheses around that x plus 6. If you don't, you're guaranteed to get a wrong answer. So what do we do with this? Well, on that left-hand side, hopefully by now, the reason we're squaring that is to get rid of the square root. So that side is 28x minus 28. Here's the question, what do we do with x plus 6 squared? And remember at the beginning when I made the comment, like to fully cover everything in 1.4, you really kind of need to have your review chapter material down cold, not thinking about it. This is one of those things that this is just a small step of like something that hopefully by now your first instinct is you got to write that as x plus 6, and then FOIL it out. That this is going to be a kind of a messy problem. So it's just, this is where you got to know, what to do. So before we can do anything with this left-hand side, we need to work on this. Now, if this was equal to 0 and we had x plus 6 squared, then we could just do the square root property, or if this would equal to a number. But because of the x over here, the binomial, this makes this a messy problem. So you just have to FOIL that out and then go. That's x squared plus 6x plus 6x plus 36. So we get 28x minus 28 equals x squared. And then plus 6 goes to plus 12x plus 36. All right. Now, how do we solve for x? We have a quadratic equation now. So how do we solve quadratic equations? We either solve by factoring, solve by square root method, solve by quadratic formula. And this is not a square root method because there's x squareds and x's. All right, so this is either factoring or quadratic formula. So what's the first step in both of those? Set it equal to 0. Now here's the question, which side do you want to take everything to? Now, if you're thinking to the right because there's the most, that's not necessarily wrong. You could definitely take everything to the left. The reason I would take everything to the right in this case is anytime we're factoring doing quadratic formula, I like my x squared term to be positive, have a positive coefficient. So in this case, I'm going to move both of these over because I want my squared term to be positive, so it didn't mess up potential factoring. Oh, and by the way, you could possibly encounter this where there's like an x squared on both sides. So like if that had been x squared plus 28x, if you subtract x squared from this side, cancels out on this side, and then you're back to a linear equation. So that could happen if there's x squareds on both sides. There's not in this case, so we're not going to get that lucky. We're going to subtract 28x, add 28. So we end up with 0 on the left side. Was it minus 16x plus 64. All right. Now what? Well, this is where you either see if you can factor it or do quadratic formula. Now, I'm going to assume that by now you've done your 1, 2, 1, 3 homework, so you can do your quadratic formula. I recognize that this one can factor, so I'm going to just kind of fast forward on that. If you need to take time to factor or do the quadratic formula from this point, then you might want to pause, work through that, and then we'll start again. I've been factoring a while, so to get x squared is x and x. To get 64, there's a lot of ways you do it, but that's 8 and 8, which gives us the 16. And it works because since that's positive, we need the signs the same, so minus minus. Just double check, minus 16, minus 8 is minus 16 plus 64. All right, and then once we did the factors, we set each factor equal to 0. In this case, the factors are the same. We're just getting x equals 8. All right, so we don't have two, even though it was quadratic equation, we end up with one answer. Like I said, if you're taking your time to factor or doing a quadratic formula, pause the video, get down to here, make sure you can get those answers, and then we'll start the next step. Because we're not done. This last step is always check. Now, if we had two different answers, we would check each answer separately. Don't do them at the same time. Plug in one, see if it works. Yes or no, and then plug in the second one, see if it works, yes or no. But we only have one answer to check, so that makes it a little bit quicker. So always go back to the original problem. So we're doing -6 plus square root of 28. Now we're doing 8 minus 28. So is that equal to x, which is 8? And I said, now we got some arithmetic to do. I'm going to grab a calculator. 28 minus times 8 minus 28. Yes, you are allowed to use your calculators. And then square root of 196. If you don't recognize that, that's what your calculator's for. That is. Let me double check just to make sure. To be 14, yes. Okay. All right, so is -6 plus 14 equal to 8? Yes, 8 equals 8. So we're good. And again, since we have two answers, don't list repeats. Is that something MyMathLab will most likely count wrong? It, they may have, there's some things that MyMathLab is very picky about that I'm not. And they're not always consistent. Like I said, if on the test you gave me 8 twice, I would give you full credit because you're not incorrect. It's just typically if we have repeated answers, we only list them once. Once we start graphing polynomial equations, start talking about x-intercepts, we'll talk about how to handle the repeated answers, but for now, it's just x equals 8. Now, if it hadn't worked, if we come down here and let's say that was a +6, and then 20, is not equal to 8, then that means 8 wouldn't work. That was the only answer we got. So then it would have been no solution. All right. So that is radical equations. Yeah. So what do you do first with these radical equations? You isolate the radical, then you square both sides, then you solve, and then you got to, check your answer. Now there's not one like this in the homework, but just to talk through it, what would be the first step in number 7? The cube root of 5 to the 5x plus 1 equals -5. What's the opposite of cube root? It'd be cube root something. The cube root and cube would cancel. So you'd have 5x plus 1, -5 cubed would be -125. And then from there, you just solve. Technically, it's a cube root. You don't have to check it because it's when you cube a negative, it's negative or positive to begin with. It's that ambiguity with the square roots, but sometimes we get those extraneous answers. But this is another one of those, like if we were doing a full dive into 1.4, we would be doing more problems like that. Let me double check MyMathLab right quick. But unless I missed something, it's going to be a short video. So like I said, there's 5 homework problems. So that's just, oh, let's see. I think I mentioned this, but okay. So if an apparent solution does not satisfy the original equation, it is called, it's not incorrect. That might be the English version, extraneous. So that's if you get, if you're doing all the math correctly and you get an answer, but when you check it, it doesn't work. Math term for that is extraneous solution. So if people not watching the video, they're going to have to dig into the textbook probably and figure that out. Yeah. Oh, and this is what I was talking about in the homework. So if you check it, it works, then you put your answer in A. If you check it and like the one answer you have doesn't work, then you do B. There is no real solution. And it's not because we're talking about imaginary here. It's these either work or don't work. I don't think they put any imaginary solutions in these. Same thing there. Now I will say I will leave you to work number 4 on your own. But the first thing you're going to do here is square both sides. The radical's already by itself. So at x plus 3, you're gonna have to write that twice and FOIL it out, just like we did with the x plus 6 in that last example. But here's the thing is once you square it out and get rid of the square on this side, you're gonna have an x squared on both sides. So when you like subtract the x squared from one side to move it to the other, the x squareds will cancel out. And which is fine, because the nice thing about that is now you have a linear equation, not a quadratic equation. So the solving goes a little bit quicker. But because there's an x squared inside that square root, that cancels out the x squared you get here when we FOIL. And then number five is just what we did. So there you go. Those are the 5 homework sets. All right. That is all I have for 1.4. And so good luck with all that. As always, if you have any questions, email me. Have a good day.